I'm going to go ahead and walk through how to set up how to launch the instance on screen. Okay, so if anybody still isn't able to log in, have a chat to Chris. Otherwise, we go ahead in here. Try and remember your password. Oops. Okay, so in the services under compute, you want to go to EC2. And then just launch instance. Okay, so you need to scroll down a bit to find the deep learning one. So this is the guy here, deep learning Ubuntu. And just select. Okay, and you need to choose your hardware. So you want something with a GPU. If anybody didn't apply for access to this type of instance, you might hit a problem here. But go ahead and give it a go. So you want this GPU compute P2X large. Those are just the two things to look for here. Okay, so it's just telling you it's not free. If you have applied your voucher, then it is free, so don't worry.
Baby steps. That's the biggest
Okay, so if you haven't done this before and you don't have a key pair, you can just create a new key pair. How to create the key pair? Yeah, okay, so just choose, you can just go into create a new key pair and just give it any name, just and then just click download key pair. So you're just downloading a .pem file onto your machine. Okay, so once you've downloaded the key pair, you just click launch instance. Okay, and if you want to check how it's going, you can go into services and EC2 again. And you should see one running instance here at the top. So you can just click on that to check. It's probably still initializing. Yeah, so it's still initializing here.
When you go into the EC2 console, you will see multiple machines. Okay, and obviously you're going to need to be able to try and track which one is yours. When you've created a private key, if you just scroll this bit up for me, Keelan, you will see for each of the machines that are in the console, you will see the key pair name that's attached to it, and that will tell you, hopefully.
Don't call it my key pair.
Yeah, don't call it my key pair. But if you have, and you're the only person in the room, you'll be fine. But for the moment, that's probably the best way of tracking it. Alternatively, we would use tags to be able to label the machines. But just for today, have a look for the key pair. If anybody's got any questions or problems, then give me a shout.
Just to note that my slides are all available online, and the URLs for them are actually embedded here in the GitHub instructions. So if you ever want to look at them again, there they are. First one is the softmax network.
Any chance you can make that?
Font bigger.
Yeah.
Yeah. Better? Is that okay?
Yeah.
Okay, so in the main function, the first thing we do is import the data. And because MNIST is a sort of very commonly used benchmark set, TensorFlow has built-in functions to do that for you. So it's very simple. It reads in a training set and a test set. So there's actually 60,000 images in the training and 10,000 in the test set. And this one hot encoding is set to true. And the next thing we do is create the model. So this is the graph building that Peter talked about in his talk about TensorFlow. So we're not actually doing anything yet. It's a bit like writing a function. You're setting everything up so that when you want to actually run it, everything is in place. Okay. So we're just putting in placeholders for our input x and the placeholders for our weights and variables. We say that we're going to initialize them to 0. We haven't actually initialized them yet because we haven't started our session yet. And we set our y values, which is our network output, to be matrix multiplication between x and w, the input and the weights, plus the bias. So that's exactly the linear term that I showed you before. And you can see that we don't apply the softmax yet. That's a sort of a technicality why we don't do that yet. You don't need to worry too much about it. It does get applied, but only when we're calculating the loss. We also set up a placeholder for the training labels that we're going to feed into the network. And here we define our loss function. So we're using the cross-entropy function. This TF is TensorFlow, and TensorFlow already defines this softmax cross-entropy with logits function, which basically applies the softmax and calculates the loss all in one go. And it turns out that that's the most numerically stable way to do it. And for that we're going to need the labels, which are y underscore, and the logits, which is the network output y. We're also defining our optimizer, which we talked about gradient descent is the most basic type of optimizer. That's what we're using here. So again, you can just take that straight from TensorFlow libraries. It's all defined for you. 0.5 is just a parameter. And you tell it that in optimization you want to minimize this thing that you already defined, the cross entropy, which is the loss. Okay, so we've sort of said everything that we want our graph to do. And now we have to create our session. So only when you create the session, things start to actually happen. So this is one way in TensorFlow to create a session with the tf.interactive session. Okay, so the first thing we want to do now that we're in our session is initialize our variables. So those were the w's and b's, which in this case we've initialized to zeros. Just for reference, you don't normally initialize your weights to 0. That's normally a very bad thing to do, but because this is a very baby network with no hidden layers, it's okay. And now we're going to train it for 1,000 epochs. So we're going to feed the data through it 1,000 times, and each time we're going to update the weights. Again, this is all coded for you in TensorFlow, so you don't need to worry about how the backpropagation actually works or anything like that. So we just do a printout. We grab some training data from our MNIST data that we loaded in. So MNIST train next batch 100 gives us 100 training samples. And we execute our pre-built graph. So this session.run means, okay, now we want to actually execute the graph that we made, and we want to start at the train step node. So if you look at train step, that means you want to do gradient descent. For that, we have to calculate cross-entropy. For cross-entropy, we have to actually get our logits y, which means we'll have to push data through the network. And in this train step, we feed dict is the way that we tell it what data to use. So x is this batch of 100 samples we've read in, and y is this batch of y underscore s, which is the labels. And bear in mind also that depending on how many epochs you do, I'm not going to do the math in my head, but you could be using the same training samples multiple times. If you have limited training samples and you run for a lot of epochs, you're reading it in randomly every time, you could be using the same training data multiple times, and that's okay. It can still work well. Okay, then when we're finished our training, we want to test how our network does. So we set up this accuracy measure. So here we're testing if the argmax, this is basically getting the class of the network output, and this is getting the class from the true labels. And we're comparing whether they're equal. So our comparison for accuracy is basically, did we get the class right or not? So being close to the right class doesn't count. You have to actually, your maximum probability has to lead to the right class. And then we take the mean over all of the things in our batch. And then we're going to, again, we have to run that. That's another little mini graph, so we have to run that. So we run session.run accuracy. And for accuracy, it has to again go back up through the graph, calculate the correct prediction. And you have to feed in some data. So in this case, we're feeding test images and test labels. And it's important to note these tests, the MNIST data is split into training and test. So these test images are stuff it's never seen before. So if you're doing this in practice, you should always have training data that's completely separated from your testing data. And usually you have something in between that's called validation data. I'm not going to go through the rest of the code. That's extra stuff for additional exercises that's also there on the GitHub. You can go through it yourself, but the important stuff is all up here.
So training step does one update of the weights?
Yeah, exactly.
In the beginning, we have a Y that's being filled in with training data, right? And
X is the training data. X is the input data.
X is the input data.
Yeah.
Okay.
So
Where
Y is the output from the network.
Where's that data coming from?
It's so in the sorry, go back.
So when we're defining the
Right up here at the start, we read in this MNIST data, and then we create our graph with just placeholders, and only later on down here after we create our session, then we tell it what data to use. So here, in this line, you feed in this data, and so batch XS is a batch of training data taken from this MNIST stuff that we read in at the start.
For the first example, we're using we're comparing handwritten numbers and trying to figure out
which digit was written. Yeah.
What kind of we're feeding in a matrix with 1 and zeros if it has a bit of color.
So the MNIST data is actually stored as flat arrays, so they are actually 28 by 28 images, but they're stored as flat one-dimensional arrays by 784. So that's the networks we've looked at so far can only take one-dimensional arrays, so that kind of suits us. So we're reading in a one-dimensional array, basically ones and zeros, and there's some grey values in between, so it's not a completely binary image.
So just on the data, you'll notice that the first time you run that, it'll be quite slow. The slowness is actually downloading that data set because that's built into TensorFlow. When you run it the second time, you notice it's a lot faster because it has that data cache.
Yeah.
That data is built into TensorFlow.
The ability to bring it down.
Yeah, so TensorFlow just provides convenience functions for people to pull it down quickly. You can download it separately online if you write your own read-in function, but because it's used so often, a lot of the...
How would those data sets generally be prepped? Like, are you kind of going to known data sources? So if you come up with a random set of images, how do you define the matrix to work with, or is there a kind of a guideline for it, or a set of libraries, or
the matrix to work with?
Yeah, in other words, like you have your handwritten digits to a rule set maybe to transcribe that into the matrix, or how that works in general.
So the MNIST data is just made from digital images, so people wrote them digitally, if you know what I mean, so they're already encoded digitally. Later on, I actually wrote some digits on paper, the old-fashioned way, and took photographs, but then in order to use them in these networks, I had to convert them to size 28 by 28 and convert them to grayscale, so they don't look much like photographs in the end, but I mean, that's theoretically how you would do it.
But the answer is it's up to you, right?
Yeah, it depends on your application, what you want to do and what data you have. The only important thing is that your data should be consistent, so especially between your training set and your test set. So if your training set is taken from high quality high resolution camera.
spatial like that.
Yeah, so if you have a really high quality camera taking your training data and your test data is all from iPhones, you know, you're probably not going to get a good result because the
So training data, each one of those files is associated with a true value.
yes, each one has a label,
You've got one
yeah.
which is a handwritten one.
Exactly.
To array.
Yeah.
And the number one associated somewhere. How is that? Is that the
That's
file name? Is it a-
yeah, so here if you look here, it's in this batch YS file. Do you mean in the code now or just in the network
How is the
architecture?
image associated with the value?
They're read in together, so the way it's you can do this mnist train next batch function, and that returns two things, which is batch XS and batch YS. So XS is the samples and YS is the labels associated with the samples. So they're in order.
In order.
Exactly, yeah, yeah. So the first sample and the first label match each other, second sample, second label.